So in my last video where I was critiquing NASA's temperature measurements of Earth as 15 degrees Celsius, I made a mistake in the video, or I made a mistake in my calculations. I incorrectly typed in Earth's emissivity as 0.065 into the equation instead of what it was actually on the Cambridge University website, which is 0.605. Kind of a subtle difference and an easy mistake to make, but nevertheless it did alter the readings that I got to 505 degrees Kelvin, which is sort of ludicrously high when you think about a reading for Earth's average temperature. But it's not all doom and gloom, really, still, and the statistic put out by NASA of 15 degrees centigrade is still wrong, since I've been rerunning the calculations just now with everything sort of correct in it, and I've been looking up more accurate estimates of what Earth's emissivity really is. So Earth's emissivity, unlike what Cambridge University states on their website, is not 0.605. It is in fact 0.95. So if you put that into the equation for the emissivity component of the equation, then that yields the number minus 15 degrees Celsius, which, I mean, does sort of lend some credibility to the notion that I've been advancing that Earth's average temperature isn't about 15 degrees Celsius, it's about freezing. Because I took temperature readings for the Earth, various different latitudes on the Earth, from the North Pole to London, Lisbon, Congo, Cape Town, and the South Pole. And the temperature readings for the daytime came out at 9 degrees Celsius. For the nighttime, it came out as -7 degrees Celsius. So I think you can start to see already that this figure of -15 degrees Celsius for the Earth's average temperature isn't probably so far away from what the real statistic is. Then you can take an average, if you like, of that with the original 15 degrees Celsius put out by NASA. If you average -15 and +15, you get 0, of course, so the average will be 0 degrees. Then if you average my day and nighttime temperature readings for the Earth at +9 and -7 degrees, you get +1 degrees Celsius. So it's kind of narrowing the gap. It's the results are getting more and more precise, and they seem to be converging on something like 0 degrees or 1 degree Celsius, which is what I've been saying for a very long time. Yeah, NASA still need to update their models and their equations and still use more rigorous methods and understandings to compute Earth's average temperature. And Earth's average temperature, I'm afraid to say, is something still quite uncertain. And I've been reading through the research literature on this, and I can't find anything concrete in the literature that's saying that there's anything like a certainty of even close to 1 or 2 degrees. And I read other research that says that satellite readings have uncertainties in them of roughly 1.7 degrees centigrade. So I'm just thinking, if we can't get the average temperature for Earth correct, if we're out by a few degrees either way, then how can we compute temperature anomalies from that? How can we know really how much the Earth's temperature is changing if the 30-year average we're taking as a baseline for the temperature anomaly readings that we're taking, if that's uncertain, then the whole measurement's uncertain, isn't it? If you see what I mean. And it's still very important for the advancement of our knowledge that we get Earth's average temperature correct. And I think that what I was doing still has merit, obviously, but I made a stupid mistake. So I thought I'd come clean and admit that to you all now. So thanks for watching. Love you lots as always. Bye bye bye. See you soon.